Think about the most expensive error in the history of software. We're not talking millions, we're talking billions in lost time, crashed systems, and catastrophic failures. And it all comes down to one simple idea. This is a piece of data. Let's say it's a username. It's a box. It has a label, and inside is the actual value, John_Smith. Your code can ask for the box, read the label, and use what's inside. Simple. But what if the box isn't there? What you have isn't an empty box. It's nothing. A blank space, a void. In programming, this is called null. It's the absence of a thing. And when your code expects a box, reaches for it, and grabs nothing, that's a null pointer exception. The program has no idea what to do. It just stops, crashes, game over. It happens everywhere. You click a profile picture, but the user never uploaded one. Null, crash. You try to load an order history, but the database is offline. Null, crash. These aren't just bugs, they're system killers. And for decades, this was just allowed to happen. Wait, why was this even possible? Here's the crazy part. It was a deliberate choice. In the 1960s, a language designer named Tony Hoare invented the concept of null as a quick and easy way to say, this points to nothing. He later called it his billion-dollar mistake. He said he invented it because it was so easy to implement, not because it was a good idea. Think of it like giving every single street address in the world a spare key labeled nothing. Handing out that key is fine until someone actually tries to open the door. The problem isn't the absence of data. It's that the language tricked you into thinking you had data when you didn't. So what changed? Newer languages learned the lesson. They built guardrails. In the old way, you had a box that could secretly be nothing, a trapdoor. In the new way, you have to declare up front, this box might be empty. Your code has to check for the empty case before it opens the box. No surprise voids. It turns a runtime crash into a compile time conversation. The billion-dollar mistake taught us one brutal lesson. The worst errors aren't in your logic, they're in your assumptions. Assuming something exists is the fastest way for everything to fall apart. The fix wasn't smarter code. It was a design that made the impossible state, the missing box, explicit, and therefore impossible to ignore. If you enjoyed this 2-minute dive into a coding legacy, hit like. For more tech stories told simple, subscribe.